none of the stakeholders are left in blindside, and they one gave their information then and there, and the resolution for the specific problems are resolved very quickly. So since everyone are participating in this early, we can also have authorities participating in this early on and giving their regulations and getting the project in terms of these rules and regulations, and having it perfect, so that uh, the whole construction stage goes without any issues. Um, so what this enhances is usually in the traditional where you have a lot of data drops. So whenever a project is started, you have the architects interacting with the client, and then once the decision is made, uh, there is a whole lot of research which goes into this, and when the CD site is created, and once this data is transferred to the next the stakeholders, each of the stakeholders will be receiving just the CD set in the traditional way, where you have the whole knowledge which is gathered on the research, which is gathered, is dumbed down just to the CD set, and the reasoning behind few decisions are totally lost for the stakeholders. And as an example which sir gave yesterday, if there is a beam which has to increase, and this information is lost to the duct stakeholder, and in the site we have a duct which is hitting a beam because of the change, and due to that there is delay in construction. So all these are kind of the whole idea of this BIM is everyone sees these decision changes, and there is no data or the information drop at any stage of construction. So there is a faster delivery, and it is comprehensive. Everyone can give their inputs together in real time, and there is higher accuracy. There is no rework as such. But even today, like even the processes today are not all to the ideal. They are getting there. There's a lot more things which have to be uh, reformed, but we are pushing the limits of getting the project done at a faster pace compared to the traditional way. So the advantages, as we discussed, you have a common data environment where each and every one can each and every one of the stakeholders can give their models, irrespective to which software they're using. They can just upload their model, and everyone has this interface where they can uh, give comments on a specific issue, and collectively you have a good outcome, or a quick outcome of construction, because time is of essence, right? You every each and every minute is very important, each and every hour is very important. And and we have to go through in a fast-paced society. Even construction has to catch up to this, and that's the reason you have everyone giving their inputs, and you have a better outcome of the construction. Uh, so this is a kind of graphical uh, representation of what we were talking till now. In traditional, you have the pre-design, schematic design, design development, and then you have construction documents which are prepared, and then you have that distributed to different stakeholders, and then you have different buyouts, which in turn starts the construction and closes out the whole project. When compared to the BIM integrated thing, at the conceptual level, you have all agencies right there helping each and every stakeholder is helping each other, giving their inputs right at the design stage, where you have a criteria design, detailed design, so that it, even from the design stage, you have inputs from all stakeholders, and these are implemented in the design without any rework. And then you have implementation documents rather than construction documents. You have shop drawings, or basically the ones which are used directly from fabrication and brought into the site. We can go to that extent and use this to the fullest, and then you have less time which is spent in explaining the project to different stakeholders, and the construction is done very quickly because everyone knows what happened during the design phase, and it is being closed out very quickly. So we will be in most of our projects, we have been working with US projects a lot, and they follow AIA standards. And this has been a norm, or where you have the level of detail in the model, which is kind of getting nullified to level of information which is embedded in the model. But these are the the basic or the elemental concepts of BIM when it was started. So we kind of still, or AIA still kind of follows this. So what we can assume is during the conceptual stage or the design phase, you have a basic idea of or the designer has the basic idea of what shapes the building form can take, or that it's the shape alone. It doesn't have any information of material as such. So basically that's LOD 100. Then once it starts getting detailed out on the schematic sizes of each rooms, then that's when it becomes LOD 200. Then when we add in information about what wall types, what are the each and every intricacies of each room, like what material is used where, how many windows are there in one, uh, in maybe north facing wall. So these details, once they're added into the model, it becomes LOD 300. And from there, once we give it a form or a total uh, stage where it can uh, be represented as construction documents, or we can extract these documents from this model, that's when it becomes LOD 400. And this whole thing can be the design phase. But once we are creating these construction documents, once it goes to the manufacturers, they add in their information, like what what is the make, what is the product, or what is the actual screw which is being used. These information are added in more, which gives more detailed uh, understanding of how it is being constructed on site. Then those are the shop drawings, or basically the final drawing, where just using that we can construct on site. Then these are LOD 450 models, and during the construction phase, as it is being constructed, the model can also be updated as per site conditions, if there are any changes to the actual design, where a pipe or a duct is moved a little lower to the beam, then this has to be reflected back into the model. If there is that feedback, then the final model, which actually represents the construction on site, is as built model, which is LOD 500. So this comprehensive model totally is given to the maintenance and management, the facility management, who can use that model to check the whole life cycle of the building. So this is the information levels, which can be embedded in a BIM model. So we did a project in Hyderabad. This is done in ArchiCAD. It's a duplex house with a pitched roof, but what we did was, apart from the design, we took that ArchiCAD model into Revit and added services, so MEP services. And we also, actually, this design was for a structural engineer, so he gave his inputs as well. So this was a totally coordinated model which we did. And the construction for that was very quick. So what we like, when we get a project, as soon as we get a project, the first thing we do is add a project site location. What this does for a model is, it gets in many of the tools, Revit, ArchiCAD, or Bentley, you have, as soon as you give a location, the software in the backhand gets the information of the weather data at that location. So uh, as soon as you give the site location, it gets the weather data, and then you can start doing solar analysis, energy analysis, just by the basic site location information. And the best part is, once you create the model, it also has the embedded latitude and longitude information. So everyone knows with GPS tracking which element goes to which part of the building. And it is very easy now to understand, apart from the grid locations which are used in the site for constructions, directly the GPS can be used, and to track where each constructional element goes. And there are different plugins which actually make these very easy. We will be like, I will be showing few of these, specifically CAD to Earth, which is like a plugin for many different softwares. I'll be showing it in Revit environment, but what it does, it as soon as you give a location and you bring that information in, it'll populate even the site condition, and if it has GIS information of the neighboring buildings, it'll get a block model of the neighboring buildings according to its height and its shape. So the there is no longer a need for creating these mass models for explaining the neighboring site situations um, for the designer as such. Um, so once you have all this information, you of course you have to give the true north, and then you specify the project location perfectly. Uh, then that's when you have this model uh, which can give a correct detailed analysis. So I want to take a step back and kind of explain this data in BIM model. So what we did over here is we have just a 10 feet by 10 feet wall, 6-inch wall, which is modeled in 3 different softwares. This is from AutoCAD. The one which is being selected, which is in blue now, is from AutoCAD. The one to the left is from SketchUp, and one to the left more, or the last one is Revit. So Navisworks, we are using Navisworks interface to see what all information is embedded in it. Uh, so basically, if we see, this is like the this is the CAD model. You can see CAD 6 wall drawing file, and as soon as I select it, it is a 3D solid. It just tells me that. But in the properties, I just have 3 different tabs, which basically gives different information about that specific element, which is created in CAD. And you can see it just tells me kind of which layer is it in, what is the file name, and what is the material. Currently it is just showing index 7. That is basically a color in AutoCAD, which it is using because here, and it is saying it is a 3D solid. Apart from this, we don't get any information from the native file, right? Then we have SketchUp. SketchUp, what the whole concept of SketchUp is, it does modeling with using the surfaces, right? So now if you compare this to how an AutoCAD file is being selected, if you see the whole object is being selected, when compared to SketchUp one, when we click, it just selects one surface, and that's how SketchUp models it. And even in the selection tree on the left, you can see that the SketchUp has one 6-inch wall, which is made up of 6 meshes because of the 6 faces, and each face is embedded with this information, right? So the source, it is just telling the source file name. It is saying that it is a geometry of a mesh type, and that's pretty much what information we are gathering from just the SketchUp file. So what we did is just use the native softwares and created these models. That's all we did. Now we are talking about Revit. Okay, so just by using basic Revit, we created. So you remember those 3 walls? These are those 3 walls, but the property which it extracted from that single element is these many tabs, and it actually goes on further. So I just wanted to show the element properties which it gathered. Uh, so even in the selection tray, we see that it is, I mean, selection tree, it is showing it is a wall of a basic wall of generic type and a basic wall. But in properties, you can see it has showing the wall type. It is showing what volume it has. It is showing the unconnected height is 10 feet. Its length is 10 feet. Then it is at level 1. It is telling which level it is. It is telling the area of it. It is telling if it has a base offset. Uh, so you can understand the amount of information or the data which is embedded in one small wall. So it is just a wall which is just drawn, and we just saved it. We did not do any other thing. And this is all the information which it is embedding in that model. So you see how a small, just a small wall has so much information. Then you can kind of take it further and understand how much information can be embedded in a BIM model uh, for different elements in construction. Like apart from just wall, each and every element will have all these information, and which is specific for its construction. So that's why we say a BIM model is successful when just using the model, not even the drawings, just using the model, it can be constructed on site. Hold on. We have a sorry, we have a small video which was done by one of our students, which kind of gives a clear picture of what BIM is. So I'm just going to show that now.
કરી શકો ડીપ ફ્રાય પણ કરી શકો જે કરવું હોય.
There was a loop in the audio. That's why I had to mute myself. I don't know if you got the audio from the video which was shown, but can just someone confirm if you could hear anything while the visual was going on?
There was no music or anything playing, but the video was fine.
Oh, okay. Yeah. Well, I thought everyone were able to hear the audio. That well, okay. I will share the video. There is a YouTube. I'll share the audio for that. Uh, mm, but basically, it kind of explains what we discussed till till now, where you have different consultants giving their inputs to the design, and different stakeholders cross-checking what was being decided, and finally you have an outcome uh, of that. So uh, I can. So my presentation will be jumping between the PPT as well as the uh, uh, like a hands-on session, so that you can see whatever I've been talking about. So I want to jump to a screen which basically shows the data embedded in a different file. So I'm just going to start up Navisworks. So you see these are native files from different softwares. We have the CAD file, we have the SketchUp file, and we have the Revit file. So these are basically the native files. What Navisworks does is, as soon as we ask it to open, it will create a cache file for it, where basically it is like uh, a data for Navisworks to understand what is being shown. And the best part about this cache file is uh, it is dumbed down to a very small file. So that's the beauty of Navisworks, where it can actually show the whole building, and you can actually zoom in to even a nut and a bolt, and you see the whole thing not crashing, because it can handle that much information. So let me just open. And I'll just start selection tree and the properties. Right. So as soon as I select the file from AutoCAD, you see it is showing me what is being selected, and these are all the other tabs, which tabs of information which it is basically giving out. um, so you saw what was giving out in item in the presentation. uh, the next one is from SketchUp. You have the same mesh, but apart from that, this is the information which is coming out from the native SketchUp file. And then we have Revit. So as I was showing in the presentation, okay, one second. So let me just reset it. Okay, so you see from this, you have all this information which is embedded uh, in just a simple wall. You have, apart from the element which I already showed in the presentation, I just wanted to go over what all other tab information it has embedded in it. So it has the element ID, it has the Autodesk material which is being applied, masonry, CMU material. Then we have what kind of Revit material is being applied on this, all the different properties of that. You have item properties, what wall it is, what is the graphic user interface ID. This is all to select it uniquely. Then we have phase created. So Revit has different phases. So if it is like a demolition phase or a new construction or a renovation, so those kind of things, it also has that information in it. Then what are the type parameters which are there in that specific wall, and if we have added any timelines, you can also see that information in this. And finally the material again. So you see just a simple wall from Revit has this much information embedded in it when compared to the other software. So the definitely it adds on more value, but at the same time it also equals to how much investment you're putting to get that software, right? So not all stakeholders can get their hands on these softwares, or they have a cheaper alternative. That's when you have the interoperability option, which started off in BIM, where different stakeholders can work in their native tools, and then they can send that information so that it is kind of hosted on a single server, which basically everyone can see. Okay, so I can. Yeah, so I'll come back to the presentation. Uh, Interoperability. So what this term basically means is what I just explained. So everyone can work in their own environment, whichever they are used to, and host these files on to a common data environment where the collaboration is very easy. And irrespective to which screen you're seeing it from, apart from Mac, PC, phone, tablet, it it kind of gives the same uh, functionality for everyone, where all can interact and give their inputs then and there, and you can get this whole information exchange in this environment. And there are different tools which does this, which has these features. So I'll be showing few which we are using in-house, and we have been using in our company as such. So first one which I'll be showing is Bluebeam. Bluebeam by itself is basically like a PDF viewer, Bluebeam review. That's basically the name of the software as such, but uh, it is developed for construction industry, that the because most of our files are really huge, and the time it takes to open these files takes a lot of time, right? And you don't want to waste time. So this software basically um, is, even though Adobe is the conventional uh, uh, software which actually created PDFs, what we saw when we are using this is it is much faster when we use Bluebeam by itself just to open PDFs. So um, Apart from just the PDF functionality, what it does is it has this something called as Studio, Bluebeam Studio, where repository of all the PDFs at one location where everyone can access and give their inputs real time, and the said person will get notification that so and so has been changed or some comment has been added. Uh, so let me just pull that up in my system. So it was offline as soon as I opened it. That's why you had that big logo of Studio. But I just clicked over here when it became online. So it just logged in as my user. And these are the two, think, let's see. Yeah, so these are the two projects which are going on currently. Actually, MPK 21 is already done, but we still have access to those files. But basically, this is like a centralized location for everyone to upload PDFs. So this is basically like a 2D interoperability where everyone have their drawings at one location and everyone knows if there's an RFI or anything is changed. So let me just open any one file, doesn't matter which. So this is a project. We will be talking about this when we are doing project overview. But so this is the plan, and we are like the drywall consultants for this project. So we have to make sure all walls have been built correctly. So since this is metal stud construction, so what we do is we populate all metal studs for each wall according to uh, the openings or the hits of these walls. We create openings. We have jams, headers for the openings. So each wall, apart from showing its location in the floor plan, key plan like this, we do have uh, its panel elevation. So that specific wall will look like this inside with all the studs. So you see there is specific tags for each stud. You have each stud and they inside the field manager or the yeah the field manager will have iPads, and all they need to do is just click and they can come to this screen. They have QR codes where they can scan this in their phone and they can get this uh, like the way it is being done in site right now is they have this panel, so and so panel is at that location according to the key plan. So as soon as they get that number, they just scan this to get the quantities. You see all these are extracted directly from the model, and they get all C zeros which are of 8, which is of this type of stud, has this much length. So they know exactly what is the quantity required to build this whole wall. and they also know what are the openings. So if you see, they are all the trade files have been grayed out, and this is a duct, this is a cable tray or a pipe which is going through there. There is a light right above the door. Then we have different ducts going through the whole wall at that location. You have different other wall hosted trades at that location. So uh, pretty much just by seeing these in their iPads, the field knows what's happening and why things are happening the way they are. So they know, they can just correlate, and if there is any discrepancy between the locations of the set trade, they can also mark it up, and then we can update the model then and there. Also, they can just make a mark and send it to the trade as well. So the trade also knows what's happening on site as they are building, right? So it is really so this is like a repository of the 2D information, but what takes it further is your ability to add what uh, has been affecting this specific panel. So what happened was, in this project, you have a corridor wall. This is basically a corridor wall. Let me just jump back to the floor plan. So we have a corridor wall, and for some unknown reason, the cable tray could not be hung from the slab. So what they wanted what they wanted to do is host it from the wall. So suddenly this wall had to be beefed up to take that load, right? So there is an RFI which states that, so we know this specific RFI what to refer when they are constructing this, and these are all real time. As we update the model and then we upload it, they have the latest file. The field has the latest file in an hour from what we do. So as soon as we print, they and we upload, they have the latest information, and it is being reflected on site for the field manager to work on. So very um, uh, informative, or very well use of 2D repository for getting interoperability between different trades. Of course, I'm just showing you what we did. There are different trade elements which we might have access to or not. It all depends on how much access has been given to us. So I will basically show what I can show, or what I'm allowed to show. So since this is our work, I can show this specific thing. So this is basically the 2D in interoperability, you can say. So I'll just close these. Okay, then we have Navisworks. This has been widely used for crash detection and simulating the construction of how it is being done. But as I said previously, Navisworks does a good job where it can bring in all the different models and overlap them and show the construction issues. So what screenshot I have in front of us is basically kind of showing all the different models from different stakeholders, and you see currently there are quite a few files which are brought in, and all of them have been overlapped according to the correct shared coordinates. And and we can do the clash detection, where we can check the constructability. You can Each and every trade has an idea of what is happening. So for example, like the routing of pipes can be done beforehand, when they know what is being obstructed in their path, to reroute their overall route. Uh, so each and every trade has this information right as soon as they start modeling, and we have these coordination meetings which are being conducted by the general contractor.
Hello.
Yes,
Yes, sir. I have one question regarding a
yes,
Navy's work. While
yes.
doing a clash detection test, among the all the services,
Hmm.
what is the sequence of that clash detection should be? Means what was the sequence? Means if first one is the HVAC system, firefighting or something. I want that sequence, sir. Uh,
Yeah,
Priority.
it's a good. Yeah, sorry. Yeah, it's a good question. So the way it is being handled in our projects is we usually have a general contractor who does all the clashes between different trades. It is mostly like a cross product. So each and every trades model is being clashed with all other models. So there is no set like a rule that first MEP, first mechanical file is being clashed with all others, then structural. Of course, in construction, I would say structural model will go first. Apart from the architect's design, you have the structural being the foremost for the building to stand. So usually structural clashes will be done first. Then on it is done uh, actually not in a sequence, because everyone's model has its own importance. So what usually general contractor does is he clashes with each trade to all other trades, and whatever is the outcome, usually if it is like a single thread hitting another single thread, these are supposed to be resolved within themselves. So yesterday you heard Santosh sir talking about these big room meetings, right? So usually what happens is we have these meetings um once in once in a week or twice a week, depending on the construction of the project. They What we do in these big room team or coordination meetings is uh, we usually resolve the clashes which are between two or three trades, more than two or three trades. So any clashes which are between just two trades, they have to be resolved within themselves. So that's how it is being handled, all because everyone's time is of essence, right? So we cannot spend time when only two people can resolve it. It is when you have three or four people involved, that's when you can take the time in discussing what can be done in that situation. But coming back to or to the answer of your to answer your question, uh, there is no set rule in which there is a sequence uh, of clashes which is being done between different trades. But the way it is being done right now is each and every trade is being clashed with the other trade files, and their clash count is being uh, noted down, and depending on how many trades it is being hit consecutively, that takes precedence. So if a single trade is being clashed with maybe five other trades, then that takes priority, and it has to be resolved in these big room meetings. And once it is resolved, then we can go to the lower clashes priority levels. Hope this kind of gives a like an insight of what's happening with us while we're working. But yeah, there is no such rule that in sequencing of clashes as such. Sequencing of construction, that's another ball picture or ball game altogether, where you kind of plan in what is being constructed on site first, and depending on the sequencing, eh, the general contractor can give a direction on who can go inside first, and then that planning can be done separately. But for clashes, there is no sequence. It is like a cross product between all trades. So, yeah, does that answer your question? Okay, I think I can carry on. So, uh, yeah, so Navisworks, what it does is it brings in all the different file types together, and kind of displays what's happening on the virtually on site. And usually these clash detections are being done 6 months prior to what is being constructed on site. So pretty much when it is being constructed on site, everyone knows exactly where what happens, and they follow that, so that the time spent on field is minimized to the least, and they can focus on getting the construction done within the given set amount of time. So it's like you know exactly what is happening, where what clash is happening, and they can focus on the construction very well, rather than getting surprised with why there is a beam uh, with more depth compared to what was there in the drawings, and then this whole notion of rerouting everything and creating a big lag in the timeline. So those all are cut down basically. um, so I'm just going to jump to a view in Navis where I want to show one similar instance of how we are using Navisworks. So one thing I do want to tell, Bluebeam, which I just showed previously, is like a server or a cloud hosted thing. So currently, I think Bluebeam is available only on iOS, and it is not yet developed for Android as such. But uh, but it can be accessible via iPhone and your systems. Um, so and any browser, doesn't matter which. If you have a browser, you can just open these files and check what is happening, right? So let me just show you Navisworks, a sample file. Okay, so this has all these files embedded in it, and this is like one level of a project which we are currently working on. Um, and we have the grids, which basically are like overlapped from an AutoCAD file and brought in. So like at least you are not lost while you're roaming around in the model as such. So what we can do in Navisworks is we have these viewpoints where if you want to talk about a specific issue and you want to uh, directly go to that location, you can create a viewpoint and and discuss what's happening. So I wanted to show this specific instance where you have a rated duct work which is going, and because it is rated, we are also encasing it with a rated wall all along its location. But this was the architect's intent. So basically, the architect intended that this pipe gets enclosed within this space, but uh, because of the depth or the the slopes, it had to go down, and we had to reroute it and restructure the enclosure as well according to this. So this is the architect's model, and this is our kind of updated model to what is happening on due to this RFI. So you see all the different trades which are there, and this specific pipe, you see it has I don't know if you can see the transparency from the transparency, but basically this pipe kind of slopes down and then slopes back up, um, and goes to the other side. So we know model while we are doing this, that where do we need to enclose it, where we need to dip the enclosure. Of course, this is not yet updated. This side we are still working on it, like we are doing sign off, but the other side we did work on. So these there are dates where few rooms have to be finalized. Those are called as sign-offs in these coordination meeting. So few places, everyone have to populate at the right location, and once everyone are sure where they are going to go, that's when the GC or whoever in charge is going to call it signed off. So what happens during this sign off is whoever model is at a location, it is understood that they will be constructing on site as per the location which is shown in the model. So say now currently the pipe is showing already in clash with this wall, right? So what if this has been signed off, and let's say the pipe is installed correctly, but the wall maybe uh, they did not yet install this wall, right? So what happens is, if this is signed off, it is on the wall subcontractor that he has to take care of this whole thing, and it is all on his it is all under his belt, so he has to take care of the costs and everything. So it is very important that before sign off, every model is updated perfectly and everyone are on the same page. And if someone is delayed or if there is any RFI pending, then there will be a note so that once that RFI is resolved, that's when they will revisit this specific area. But pretty much that's how a specific task or a specific room is being signed off, and it is being updated. So yeah, so this basically shows like an overall view of this. So let me just enable sectioning. I will switch on. Okay, I'm just expanding so that we can see a little more. Yeah. So basically it has all these different models. So we can isolate a specific model. uh, let's say so this is all from mechanical wet, I guess, and this is all the model. So each file has the specific stakeholders information, and once it is collectively brought in, we run clashes through this, and we have a coordination meeting accordingly. So this, even though it is like a single software, so if we can see what are all the file types which it can open. So you see it can open the first three are Navis, it can open 3D Studio Max, it can open even CATIA, microstation files, DWF Autodesk, IFC files, uh, inverter files, so Pro Engineer, Pro E files, Rivet, Rhino, SketchUp files. So pretty much any 3D modeling software will it will try to open. There could be a few limitations, but as far as I know, Navisworks usually open any 3D model. But even if it can't, you have IFC, right, or FBX, where specific softwares can be exported to these file types, and it can be open. The thing about this interface overall is that everyone has to submit their model at a single location, and there should be someone who is actually bringing them together, and and then conducting the meeting. So these big room meetings, what we were talking about, you need someone who is handling this software while the meeting is going on, and and like and that person will be conducting these meetings. So it is pretty much like you have a centralized location where you are uploading, like a Dropbox or a Google Drive or any cloud server, from where the models are being brought into one location, and it is being appended to Navisworks file, and you are seeing all these. But the challenge is if you don't have a server at that location. Let's say you're in a trailer at the construction site and you don't have access to these file locations, then what's the situation, right? So uh, so Navisworks pretty much is almost like an offline in interoperability of 3D models, where they have to be brought into one location for it to be embedded into Navisworks, and then done these clashes um, or the studies. Uh, so then we have this BIM 360, where it is uh, like an online cloud service, which does pretty much similar to what Navisworks does. You have an online server where everyone can upload their models, and that by itself has different tools where it can do clash detection automatically. It can generate clashes and then send notifications to the specific uh, uh, in stakeholder that these are the clashes and these are to be resolved by so and so date. So BIM 360 has quite a few like parallels or verticals, which kind of tackles on different things. So if you just go to their website, and you go to products, so you have all these, you see. So similar to Bluebeam Studio, BIM 360 has BIM 360 Docs, where they have the CD set and all the document management software in that. Then you have design, BIM 360 Design, where you have design collaboration and work sharing. You have Ops, which does facility management, which is basically facility management software, which is from Autodesk BIM 360. You have BIM 360 Build, which does quality control, safety, and project management. You have BIM 360 Plan, you have Coordinate, you have Layout. So basically, BIM Autodesk is giving all these features with different verticals of their products, and depending on what you are going to do on the site or what you're involved in, you can take that specific product and use it so that it can be collaborated with all the different stakeholders as such. Uh, so So we have pretty much the same Navisworks file which I showed you. It has been brought in BIM 360 Glue. This is basically like the product where they are going to uh, embed all the files in one centralized location and show it in a browser. So basically, this is a browser. So I just cropped out the browser interface out of this, but basically, open the file, it shows the model in 3D, and you can go and add your comments here itself. And as soon as you make a comment, that specific stakeholder will get notified, um, and they can get to it according to the priority. So it is pretty much what Navisworks does offline, but it is an online service. So this is basically BIM 360 Glue, and the term they use glue is just to glue our models into the server, into BIM 360 server. So what I showed you in the previous Navisworks is like one level from this whole model, but that's pretty much what it is. So I think we are running close to the end of first session. So I will stop here and I can open for any questions if anyone has um, before the first break.
Thank you, Trinath.
Yes, ma'am. Thank you.
Let's see.
Hello.
Yes.
Yes, sir. In the Navy's work, sometimes what happened, the ceiling height was very low, and we have to run all the services among that ceiling height. So, so there, in case, what is the role of pipe routing in the modeling while doing a clash detection?
The instance which you gave, it is very tricky, because if you say a ceiling level is such that no trade can go effectively, then everyone has to kind of approach the architect and say, okay, our services cannot be routed with this ceiling height, and you have to definitely lower the ceiling, and call has to be done from the architect, and that's where it will be pushed and the RFI will be made, because irrespective to the building, end of the day it has to be constructed, and if you have any service which cannot be in the void space, then it is a problem. And of course the architect also has to go through the rule book and see what is the ceiling height required for that specific room, and decide on how much he can leeway it, or he can also decide on the material what is being used, and kind of suggest full construction and each ceiling. But uh, but the the thing is, uh, throughout, because any of the services, if you uh, take, they cannot clash with anything else. There is no stakeholder which cannot uh, run their service through the service, right? So uh, this uh, the
Trinath, I'm going to mute everybody. Please unmute yourself.
Thank you,
yeah.
sir.
Trinath, go ahead and unmute yourself, please.
Oh, yes, ma'am. I
Yeah.
thought I unmuted myself, but again it
No,
mute.
I have this control to mute everybody because we are getting this background noise and it will mute even the presenters.
No problem, ma'am. Okay, so yeah, so as I was saying, this what is the use, or depending on which stakeholder you are, you have to bring in the models and reroute according to the other models, right? So to answer your question, that uh, if the if the concern is with the ceiling height and it is too close to the slab, definitely it has to be brought up to the architect and asked what can be done to lower the ceiling, or uh, to bring to the notice of the architect. But uh, if all the services, if they have their model, so okay, there is one other, I have to take a step back. So the accuracy between the models and how it is being constructed on site currently in US, the projects which we are doing is like 1/16th of an inch. Okay, so whatever we have in the model is almost accurately built on site, because they have total stations. You have these robots which actually it's like those Roomba which goes and cleans the floor. They have pretty much similar robots which can go and mark where the walls are, and on the concrete site it it takes exactly the XY location from what is being modeled, and it is being constructed on site. So the only discrepancy is with structural concrete cast in place, cast in site situations. So because of that uh, irregularity, there is like a 2 inch tolerance for concrete. But apart from that, rest all are with 1/16th of an inch accurate. So now when you compare it to, again, your question, if all the trades are exactly modeled at the right height with everything intact. So like the the hanger rods, the exact nut and bolts for the hanger rods for each trade, if they are modeled accurately, and you have kind of a buffer height between each trade, then definitely it can be constructed on site as long as the means and methods are used perfectly. So I know it's a long answer, but hope it gave an overall picture of what you asked.
Any further questions from anybody? You can raise your hand or unmute yourself while you ask it, because we've noticed that everybody, most of the participants are using their mobiles to log in to the Microsoft Teams. So when they use the link, when they click the link, it just um, opens the meeting, but probably will not show them the chat window. So if that is the case, I suggest that you can raise a hand or unmute yourself and speak. If you have created a login on Microsoft Teams, then you will be able to type your questions on chat. Anyone would like to ask anything? We will have questions on this tomorrow's quiz. No, I'm just kidding. I'm not trying to scare you. We will, in that case, we will take a break for 15 minutes, and it's almost 11:35. So 10 minutes break, come back at 11:45, if that's okay, Srinath?
Yes, ma'am.
Yeah, okay. We'll come back for the 11:45 session. Thanks, everyone.
Thank you.